My name is Andy Fox. I work for Blinker, and our office is downtown. Downtown Denver. Yes, I guess I should clarify that. So what the company does is we're trying to enable peer-to-peer car sales. So if you're buying from a person on Craigslist, think about using the Blinker app instead. It'd be great. And tonight we'll be talking about Kotlin for Android. And if you're not an Android developer, you'll probably still get some decent stuff out of it, especially if you do Java. So my goals are not to go in really deep detail tonight. It's more just I'm going to talk about some general language features and hopefully get everyone interested in using it. So first off, what is Kotlin? It is a statically typed language that's targeting the JVM. It was made by JetBrains, who makes Android Studio and the amazing IDE that we all use. And it's 100% interoperable with Java, which is great. So the idea was JetBrains came up with this language because most of their products are built in Java. And they kept finding shortcomings with it, and they're waiting for Java to keep updating. And they started making their own language that would work with their current product line. So that's why 100% interoperability was important to them. So it's a little different from Scala, where it's kind of interoperable, but then you run into cases where it's not. In this case, it's fully interoperable, which is nice. So what's wrong with Java? It's very verbose. If you're used to writing Java at all, there is a lot of code and boilerplate you constantly have to write. It has nullability issues. You never know if a variable is going to be null or not, and our code is littered with if and else statements. Is this null? If it is not, then do this, etc., etc. Kotlin can help with that. And we're lacking other modern language features like lambdas and higher order functions. And another real big issue, and this is probably one of my favorite parts of Kotlin, is we can't edit classes without extending them. So in Java, if we want to add functionality to a class, you usually have to end up extending it, or you write a util function and you're wrapping it around it. And that ends up with this giant folder or package in your project with tons and tons of util functions. But if you did want to extend it, you end up in inheritance nightmares, which are never fun. So we'll start off with some basic syntax just to kind of get used to this, just so you know what you're looking at. In Java, normal function. In Kotlin, you have the fun keyword followed by the method name, and the variables come first before the type. And then at the end, the return type is at the end instead of in the front. So it's not much to that. The nice thing is if you have a one-line function like this, we can inline it, so you don't have to have the brackets all the time. Variable naming are just vals and vars. So this is what you'll see. You won't see the ints beforehand. The types come after the name. And if it's a val, it's automatically immutable. So once that value is set, you can't change it. So this leads to better practices down the line. And the vars are mutable, so if you do want to change it, you can change those. So also, getters and setters are a little different. You will attach them to the var declaration itself, so they'll go right below it. And you'll declare the get function and the set method right below. And you don't make a separate full method like you would normally in like a Java Bean or just a regular Pojo. And that what it also adds is if I say email equals a string, it will use that set method underneath the hood. So it cleans up the syntax as well. Null safety. This is one of probably the biggest benefits we can get as Android developers. Android has lots of nulls around. You have to constantly check. They do that for efficiency purposes, but it is kind of a pain to deal with. So if you declare a variable with a question mark at the end after the type, you're specifically declaring this variable could possibly be null. And what this enables is the compiler will not let you access that variable unless you check and see if it's null first. So if I do check before I access it, it will compile. So no more runtime null errors. Let's look at another example. Let's say I also declare this variable name and it could possibly be null, but I set it before I do anything. Anything I call after I set that value, well, it's fine. It lets you compile, so you don't have to do if-else checks afterwards. So, and then we can go on for further features. This person could possibly be null. If we want to access the name of that person, we can put a question mark before the dot, and if it happens to be null, it will return a null immediately and we won't crash. You can continue to do that with chains. If I'm trying to get to the name of the department head of this person, if anywhere in that chain of calls one of those things is null, it'll just return a null immediately and we won't crash. So that's nice if we're trying to get like a length or something else out of this. But what if we don't want length to be null? We can use this special operator called the Elvis operator and define a default value to return if any of those things ends up null. Another kind of small feature, but it's pretty nice once you get used to it, is the delegated properties. You can assign someone else to be responsible for setting the values. So this would be the basic syntax. And Kotlin provides some real basic delegates that you can use right out of the box, like the observable. And this is not related to Rx at all. This just happens to be what they called it. But what happens is, if you look at this observable, anytime we call set, it'll notify that print function and we'll print out the old value plus the new. So after calling these two lines, name equals first, name equals second, we actually print out no name first and then first second. So you can set up things like if you have views to update anytime a variable updates, you could set it up, say, anytime this variable is updated, go tell this view to update as well. There's also lazy initialization. So if you have a really expensive operation that you want to move to a later part, you don't want it to initialize right when all your views are initializing and slow down the screen. You can put all your complex initialization code inside of this lazy block, and it won't be run until that value is accessed for the first time. And then smart casting. In Java, if you're ever checking for specific types, you will have to check for the instance of, and then you still have to wrap that in a cast right after. In Kotlin, they allow you to check the type, and then anything inside of that if statement is already automatically casted. So at compile time, it knows to cast it. And then this is just kind of nice for logging purposes or just building strings in general. In Java, you have to concatenate the strings with the pluses over and over. Kotlin allows you to inline that with the $. And underneath the hood, if you're curious, it still is using a string builder. So you're not really losing any functionality there as far as efficiency goes. It does clean up your code a little bit. And as far as value classes go, we all use these things pretty heavily throughout the app. You represent your users, you represent whatever Pojo objects you have by building these class objects. So as an example, I have this user here with only 3 methods. If we want to follow good Java practices, we need to generate all the getters and setters and the constructor for this. So first we'll make the constructor, then we'll generate all the getters and setters. Now if we really want to compare this to other objects of the same type, we'll have to implement the equals. So then we have to keep writing more code. If we want to use it in a hash set efficiently and print out meaningful log statements with this, we'll also have to override the hash code in toString. And that's a lot of code to write for just a value object with only 3 variables in it. So, and if we're using it, this is what it would look like in Java. And let's say I wanted to make a copy user 1 on user 2, except only change 1 field. I'd have to go through and manually set everything. Or you could use a builder pattern if you want, but still it's not ideal. So let's try something a little better, but we'll stay in the Java realm for now. There's a library called AutoValue, if anyone's familiar with that. If not, AutoValue generates immutable objects for you. You define an abstract class with abstract fields, and it will automatically implement the equals toString and hash code for you. And it gets real nice if you're generating a lot of objects, and especially if you're really into RxJava, comparing these strings or values. If you want to make that a little better to use, you can generate the builder with AutoValue as well. And if you want to make a copy of a class but only change a few fields, you can add the toBuilder abstract method, and it allows you to take an already made instance, change the fields you want, and then spit out a copy. So then you have 2 immutable objects. And then what that would look like in Java is something like this, where we can use the factory method, we can use the builder. If we want to copy, we can say toBuilder, change the last name only, and now the user copy has the same first name and ID as the user 2 does. Now, how can we get all that functionality with Kotlin? And we're done. It's all you need. There's a special class in Kotlin called a data class. And if you mark your class that way, you automatically get toString, you get equals and hash code for free. And you also get the copy function, so you can generate immutable versions of your class, but change the values you want. So what this would look like is basically anything else. And if you notice, Kotlin doesn't care about the new keyword. You don't have to put it there, and you also don't need the semicolons. And if I want to copy user 1, but I just want to change the last name only, I can say user.copy, access it by the name field itself, and just say equals Jones. And now I have user 2 with the first name Andy, ID 1, but the last name is different.
Quick question.
Sure.
When you're doing calling it like the constructor, does it have the name parameters too, like Python or something like that as well, or no? Yeah,
you can use the name parameters in the constructor or in method calls. So that's a pretty nice upgrade, I think. We can go a little further with default arguments. So I can give default values for everything. And then when you're creating the object, you only need to set the values you want to set. If you like the default value, you can leave it there and set the only thing you want. Or you can reverse the order of the variables if you want to be more clear with what you're setting. So if you had one of those methods that has 5 booleans in it, you can go ahead and name each one so you know which ones you're setting. So let's apply this to Android a little bit. I'm sure a lot of people have written custom views here. And you'll find when you do so, you have to implement a lot of constructors to get everything to work. And often, at least in my case, there's some sort of initialization I want to happen no matter what constructor is called. And that's a lot of stuff to write out. In Kotlin, if we use the default arguments, we can set those default values, extend the view, and then Kotlin has a init block that is special that always gets called after a constructor, so you don't have to explicitly put it in every single individual constructor. So no matter what constructor gets used on this custom view, it'll always call that init block. Now extension functions is where Kotlin gets really interesting, and we're actually adding some pretty cool new features that Java doesn't have. So as an example, let's take a look at toast. If we say toast.makeText, we'll toast a hello, we have to write all this out. And I don't know about you guys, but sometimes I will forget to put .show and I will wonder why it's not working. So let's see if we can fix that. If we write an extension function for an activity, we can say fun activity.toast, and it takes in a string. And inside of these brackets, you're inside the activity context, so you have access to that activity. So that's why we have this there already, and that still works. And we just pass the text that was passed into the toast, and we automatically show it. So what that looks like in Kotlin is now we just have toast. We don't have this really long builder and .show anymore. Now it's just really concise and simple. And then add it to fragments as well, and you have toast anywhere, essentially. Now, how does that work? How are we adding functionality to a class that we don't really have access to without extending it? These extension functions are imported statically. So if you write a method for a class and you're extending something, it's actually going to import it up in the top of your level, and then any class that inherits from that will also get that extension function. But if you choose not to use that method in that particular class, you won't import it and you're not using it. So it really favors composition over inheritance. But we wrote that in Kotlin. And so what does that look like in Java? It'll still import that file, but you notice the util function that it still looks like a normal util function there. So it doesn't really give much to Java, but if you're interoperating with them, they won't really notice a whole lot of difference. But if you notice, there also is a KT that's calling the Kotlin file. It tacks that on to the file name. We can add a JVM name annotation to rename that file for the Java classes. And then it'll look like that, and they'll never know that they're calling Kotlin. So, all right, so I got to go in a little bit RxJava just because I use it on a daily. Who else uses that, just out of curiosity? Cool. All right, so some things we can do with Kotlin to clean up this code. I often see these two lines over and over and over, like everywhere in my code. Let's write an extension function for an observable that takes in that observable, applies those two lines, and then returns it. So now we can get rid of those and just call apply schedulers.
You have to get off topic, but cool thing, you can actually use transformers with RxJava, so you can also reduce that.
Yes, if you use transformer though, you have to use compose to get all that to work, and with this you don't, which is nice as well. Which, on that note, if you are familiar with this, this is a library that can go along with Rx. There's Rx Lifecycle, written by the Trello folk, and that it allows you to handle subscriptions in a more inline way, I guess, the best way to put it. I want to get rid of that compose though, because I don't like that there. So we'll write an extension function for an observable. We'll take in a lifecycle provider, and then wrap that compose inside of the extension function. So now, when I'm writing my own code, I can get rid of that compose altogether. So another area that extension functions are really interesting to me are multi-step transactional APIs, where you usually do multiple actions and then call apply or commit at the end. If you want to kind of clean that up and make sure that apply is called every time so you don't have to remember, we can use extensions to help us with that. So I wrote this extension function for shared preferences called set, and it takes in a key string and a value string. Inside of that, when I say this, it's referencing the shared preference, whatever one we're calling off of. So I can get the editor out of that. I put the string and the value in, and then I apply it. So now in Kotlin, all I have to say is pref.set, and I'm done, and it's always applied. I never have to remember that. It's not ideal. I think we can do better than that, but first we need to go on to a different subject, and then we'll come back to this. But also, you don't need this there. So higher order functions. These don't really exist in Java 6 or 7-ish unless you're using Lambda or retro Lambda, and it's kind of coming in the Java 8 updates and the Jack compiler, but it's not quite the same. And if you're unfamiliar with it, this is going to be just a quick crash course on how these kind of work. So Kotlin will allow you to pass in not just a value, but a function to another function. So where that can be useful is if I write an extension function for a list, we can map those objects into something else if we want. So let's say I take a list and I pass in a function. We can make a list and then loop through that initial list, and for every item in there, we'll call that function that we're passed in on it, and then we'll add it to the new list, and then return it. So what that gets us is, let's say I have a list of numbers. I can map those numbers to take each number individually, multiply it by 2, and throw it back in the list. So now we have a double list of 2, 4, 6, 8 on this second line. And inside of the Lambda, we don't actually need that first it, so we can shorten that a bit as well. And just as another quick example, same thing for a filter type function. We can pass in a function that chooses whether or not a value is valid in a list or not, and then we'll build a new list and only add the valid items in. So something we could do with that is take a list of names. I'll filter it out by only names that are me, and now I have a list with only me in it after doing that. And then note that you can do equality checks in Kotlin with the double equals, and underneath the hood it's still calling the dot equals that you would normally see.
What's the it again? Is that like a magic name?
Oh, let's see where I am.
Or is that any identifier?
It is just referring to the item that you're working on. So in this case, it is like the first pass through is it is number 1, and then it is number 2, it is number 3. If you look at the where the transform is being called on result.add, that function we pass in, it is just talking about the item that we're running through.
Can you say K or J?
You can rename it if you want. The default is it, but if you want to rename it, you have to say the name, arrow, so on.
Default.
Yeah. All right. So back to this example for the shared preferences. So far we kind of get rid of the apply, which is nice, but I still want the functionality of being able to apply multiple values and then applying at the end. So let's take shared preferences, make a method called edit, and then we'll pass in another extension function to the shared preferences editor. That enables us to pull the editor out of the shared preferences. We'll call whatever function was passed in, and then we can apply at the end. And then syntactically, that gets us this, where we can take the shared preferences, edit, do a whole bunch of operations, and they'll automatically be applied at the end. So that's pretty nice syntax cleanup in general. And then if you're using lambdas or these function expressions, they actually do have some overhead, and you'll be calling methods. In a lot of cases, though, you can add this inline on the function, and that will tell the compiler it's basically going to take the code you pass in, copy paste it, and it gets rid of the lambda and the method altogether, and then there's no overhead. So JetBrains has released some special libraries for Android just to kind of take advantage of all these features. Anko is one of them, and it takes all of the XML inflation away, and you can do all of the XML layouts in Java now, or in Kotlin now. And it would look something like this. And it's a lot nicer. If you've ever tried laying out layouts dynamically in Java, it's pretty terrible. This is much nicer to look at, and it'd be more efficient than XML because you don't have to deal with the XML inflation anymore. So we also have, let's say we have, you're binding all these views together. I think we can clean this up a bit as well. So normally it look like this. We can improve upon that if we use libraries such as Butterknife. Great, still doesn't get us where I want to go. If we go into Gradle and we apply the Kotlin Android extensions, we can actually use these synthetic accessors that will pull values out of the XML files, and you can directly access them just using whatever you named it in the XML ID. You can access it then, and you never have to go find view by ID or bind it. So that's about it. Got a few references. If you're interested in learning more, Jake Wharton has several good talks on YouTube about Kotlin. Dan Liu and the Trello team wrote the RX lifecycle I mentioned, and then Antonio Levia, sorry if I mispronounced that, but he has a bunch of great blog posts. And any questions? Sure.
Do you know if this reduces method count at all?
So the Kotlin library itself will add about 5,000 methods on its own. But I forget the company. They made a blog post recently. Pretty sizable project. They added the Kotlin library. Converting 25% of their code, they say they have a method reduction even after that 5,000 hit at the beginning. So if your project's big enough, maybe yes. If it's pretty small, then no. Yeah. Sure.
Is there a separate package manager, or it's all?
You can just put it in with the Java files. It works just great. Is that what you mean?
Not like an NPM. It's all Gradle.
Yeah, it's all on Gradle. Yeah.
So what do you need to do to use it in Android Studio?
Oh, good point. You just have to import it in Gradle, and that's basically it. It's just a library that you include. And then the IDE has a Kotlin plugin that you also need to install.
Does your company use it?
I am pushing for it. We haven't used it in an actual project yet, but we've messed around with it a little bit. So.
Have you found any shortcomings with it?
It gets a little weird when you're calling Kotlin from Java, but there's always workarounds, like the renaming of that Java file. But you'll never run into like insurmountable bugs. It works better if you keep your Kotlin files completely Kotlin. So if you're starting a new feature that's completely new, you can write it all in Kotlin, and you won't have any issues with it running into the Java code at all. So.
Android Studio also has a method once you install the Kotlin plugin where you can convert a Java file to Kotlin.
It's
not perfect.
It's a good start, but it usually says all your variables are potentially nullable, and you have to go through and fix all of that. And it renames stuff weirdly, but it's a good start.
How's the build time? How fast is it to run through the toolchain?
It is slightly slower. Initially, before the 1.02 release, it was terribly slow and did not support incremental compiles. Since then, it is a lot better. There is a project I've been meaning to pull down so I could compare. There is, what's it called? The Plaid project with the design. Has anyone seen that?
Oh, Nick Rogers?
No. That one's written completely in Java, and then I think Antonio rewrote the whole thing in Kotlin. And this is before the incremental compile, and he compared it in his blog post. I've been meaning to pull them both down and compile with the incremental compile to see how it works, but it is a lot better than it was. So. Cool. All right. Sure.
In terms of like the builders, how does it integrate with like other kind of code generators like protocol buffers or Thrift or this kind of thing?
I've never used protocol buffers much. It still runs with code generation fine. It does work with Dagger, it works with any annotation processors. There is a specific, instead of using apt in Gradle, you'll have to use a capt plugin that they have added to it. But besides that, they all work fine.
Cool, thank you.
Sweet.